Hello everyone and welcome back to our course. In the previous lecture, we learned how we can visualize and calculate the daily return of a stock. Next up, we're going to learn how to compare daily returns of multiple stocks. So let's create a new code cell and we will get started. First, let's make a data frame using our data reader to read stocks from the web, which we have done before, but this time we're going to only get the closing columns, specifically the adjusted closing price column. All right, so I'm going to zoom in here and I am going to grab my data reader and pass in my stocks list. I'm getting my data from Yahoo Finance at the starting time or date and the ending date. The result of this is going to be the data frame I already have. But if you pass in here that you only want one of the columns like add close, then you can get just that adjusted closing price. Now the other option is just to see here, grab your globals at the current stock and get it that way, but this time we're making it not a global variable. We can just grab this result here as our adjusted closing data frame, because the data reader returns a data frame, a pandas data frame, and we're only getting the adjusted closing price column, and that is just going to be one data frame. All right, we can also now verify that we created the data frame successfully by calling the data frame. You can print out the data frame itself, run this code cell, and you will see your results here. You have at the top, the symbols are for stocks. You have the date, and then you have values for each of the dates, and that value is the adjusted closing price. Now you can also just get the head, so you can take that adjusted closing data frame and just call its head function. If you run that, then you're going to see here just the first 5 entries, okay, just to verify that we have it. All right, now let's get the daily return for this column. And that's going to give us the daily return for all 4 stocks instead of just one. So how do I get the daily return? Well, I'm going to take my data frame, which is adjusted closing data frame, and I'm going to use the same function we used in the previous lecture where we coded out that percentage change function. That's going to give us the daily return. We can store this as our stocks returns variable. All right, then we can verify that we did that correctly by grabbing stocks returns. We can print out its value, and look at that. Here we go. We can see here for the first day we have not a number, nan, because we can't have a daily return for the first day. But starting with the second day in our historical data, we have here percentage change, which is as a decimal, not a percentage. If you wanted it as a decimal, just multiply it by 100. Some are negative if you have a negative return, some are positive if you have a positive return. Awesome. Okay, now, next we're going to learn how we can compare 2 stocks' daily returns. So for that, we're going to visualize the daily returns, and we're going to be using the help of another library known as Seaborn. So let's import the Seaborn library. This is a very commonly used library. All right, and because we're in Google Colab, we don't have to install it. It's pre-installed, but we do have to import it. All right, and now let's use Seaborn, which has many functions to create plotting, visualizations, and graphs. We're going to use the function joint plot. And let's first compare one stock against itself. Let's do Goog versus Goog. All right, here I'm passing in the X and the Y, so I'm just comparing the same stock against itself. I'm also going to pass in a data argument, which is going to be my stocks returns, which I just created here, stocks returns. I have to pass in that data frame for this joint plot. And then I can also pass in here a color such as blue or orange, better yet. All right, and really the color doesn't matter much. Okay, and now what do you think we'll get before I run this code cell? If you compare one stock with itself, what kind of line or chart or graph do you think we'll get? What kind of slope would be of the line? Well, it's like comparing the same numbers against themselves. So you should have a linear relationship, 1-to-1. So let me run this code cell and look at that. we get this joint plot, and yes, we get this linear line. The reason we get this linear slope, perfectly linear, is because we're comparing goog versus goog. That means that if I have 0, I'm going to have 0 on the y and the x. Because if you're comparing something against itself, the comparison or the ratio is always 1 to 1. And that's just because this is going to be very easy for you to understand. So you can see here we have all the data points in orange, and we can also see that we have more data points clustered in the center because that's the distribution. And we also have these bars at the top and the right. You may be wondering, what is that? Well, this is a histogram that's been created showing you the frequency of the data points. So you can see that as the number of data points increases, the bar at that exact x and at that exact y also increases in size. That's because a histogram shows you the frequency of data points. So you can see we have very few data points at negative 0.1 and also very few data points at 0.1. That's because most of the returns were around 0. Okay, and that is just comparing goog versus goog. Let's get into some fun stuff and compare two of our stocks against each other. So I'm going to create another code cell, and I'm going to use Seaborn again to make another joint plot. This time, let's compare Amazon versus Netflix. How about that? AMZN versus NFLX. Right, so I'm going to paste that in there, compared against NFLX. I'm going to pass in my data. It's still the same data, my stocks returns. I'm just getting specifically these two columns for the X and the Y. And the color also optional. Then let's run this code cell. And look at this. We get the default color blue, and this time we are getting a relationship that's not linear. It's a lot more spread out. What is the reason for that? Well, we're comparing Netflix versus Amazon. And we can see here we have the returns for Netflix versus the returns for Amazon. And because it's not 1 to 1, that's why the data points are more spread out. We can also see the most frequent data points via the histogram at the top and the right. There are so many possibilities of relationships between stocks and comparisons, rather. So we can repeat this comparison analysis for any combination of stocks inside of our inside of all of our columns. We can compare every single stock versus itself. And we can just use pair plot if we want to see all of our stocks compared at once. So for that, I'm going to call Seaborn.pair plot, and I'm going to pass in here my data is going to be my stocks returns. Then I'll run this code cell here, and we're going to this time generate a huge pair grid where we compare all of our stocks against each other as a pair though. So we have Goog versus Facebook, Goog versus Amazon, Goog versus Netflix, Goog versus Goog. And we can see here, we get that comparison. Now, you may be wondering, why is there scatter charts, but for histograms or bar charts? That's because if you are comparing Facebook versus Facebook, you're comparing itself versus itself. So the pair plot actually doesn't even generate for you that linear slope just because it's obvious. Instead, it will give you a histogram. And it will do that at these Amazon versus Amazon, Netflix versus Netflix, and Google versus Google. But for all the other ones where you're comparing two different stocks, then you will get a scatter plot. Awesome. Okay, and we can also drop any null values with drop NA. That's a useful function to add when you're creating this pair plot, because that's going to drop any null values or not a number. All right, there we go. Very similar because we didn't have many not a nulls. This is a really fast way to compare all of our stocks because all we have to do was call one function. So you can either compare functions one by one or just get a pair plot function to show you all of the possible different correlations between all of your columns in your stocks returns in your data frame. Now, do be careful because let's say you had 100 different stocks. Well, then you're creating 100 by 100 matrix, and that can actually be too large, so you'll just possibly end up with an infinite loop or an exception that says that the size of the pair plot is too large, because 100 by 100, that's quite a lot. So just be careful when you are comparing your pair plot, when you're making the pair plot, if you have a lot of columns. You may have to split the pair plot into subplots in that case, because if you have a lot of columns, you won't be able to fit it here into Google Colab. And that is how we can compare daily returns of different stocks. Coming up next, we're going to continue our comparison, and we're going to learn how we can compare a different feature. Let's compare this time closing prices, and we're going to learn how to make a different type of graph while we're at it, known as a heat map. Very exciting stuff. So join me in the next lecture where we will continue our project.